The normal curve, also called the bell curve, is essentially a theoretical or an ideal model. The normal curve or the bell curve was developed by Abraham de Moivre. One of his distinguished works revealed that the mortality rate over a person's age formed a bell-shaped curve. That is a normal distribution. The bell-shaped curve refers to a normal distribution. The normal curve became one of the most prominent models of probability distribution when Abraham's successor found that other common personality and psychological traits like weight, height, income, math, science reading abilities, years of schooling, satisfaction of health or any kinds, measures of abilities, anxieties, depressions, scores for introversion or extroversion, and so on, all form a bell-shaped curve. And we also know that income, weight, height, or even personality traits vary from person to person, but the overall distribution of income, weight, height, or personality traits in any state or country is quite normal. There are only a few individuals with extreme values, right? As you can see, the normal curve is always symmetry around the mean. Its highest point is also at the mean. It is also bell-shaped, where the width is related to the size of the standard deviation. In the normal curve, the raw scores that pertains to different measures or variables, whether they are measured in dollars, numbers, inches, centimeters, and so on, are transformed to standardized scores. We call them the z-scores to indicate their position relative to the center or the mean. Because of such transformation, the normal distribution has a mean of 0 and a standard deviation of 1. Its associated probabilities are also provided in the normal curve. Because z-scores are expressed as the number of standard deviation units from the mean, the unit of measurement no longer matter when we talk about the normal curve or the bell curve. The number of standard deviation units above or below the mean do not give any intuitive sense. Because of that, the obtained z-scores need to be converted to its associated probability to find out the percentages of individuals with raw scores greater or lesser than the raw score. We do that by converting the z-scores to the percentage of error under the normal curve. We want to assess the probability that a randomly selected student from the high school student population is overweight, meaning that they have BMIs 25 or greater. So we apply the z-score formula here. And we subtract 25 from 23, because 23 is the mean BMI for the high school student population, and we divide that by 10. 10 is the standard deviation for BMI for that high school student population. And we get 0.02 standard deviation unit above the mean. And then we translate the z-score we obtain to p-values or probabilities. We get 0.42074. This means that slightly over 42% of students are overweight. They have BMI 25 or greater. This is indicated by the area shaded in pink. And here we want to assess the probability that a randomly selected student from the high school student population is underweight, meaning that they have BMI 17 or lower. Again, we apply the z-score formula. We subtract 17 from the mean, which is 23. And we divide by the standard deviation, which is 10. and we get 0.06 standard deviation units below the mean. And then we convert the z-score to the p-values or probability. We get 0.27425. This means that slightly over 27% of students have BMI that are 17 or lesser. It means that slightly over 27% of students are underweight. And this is indicated by the area shaded in pink. What if we want to calculate the probability that a randomly selected student from the high school student population has normal weight, meaning that their BMI is between 18 to 24 roughly. And there are two steps to it. In the first step, we apply the z-score formula to subtract 18 from 23 divided by 10, the standard deviation. Here we get 0.05 standard deviation unit below the mean as the z-score. Then we convert the z-score to probability. We get about 0.30854, meaning that nearly 31% of students have BMI 18 or lesser. And then we subtract 24 from 23 divide by 10, and we get 0.01 standard deviation unit above the mean as the z-score. And then we convert the z-score to p-values or probability. We get 0.46017, meaning that slightly over 46% of students have BMIs 24 or greater. And because the whole bell curve or normal curve is 100%, we subtract the two percentages we get for students whose BMI are 18 or below and for students whose BMI are 24 or above from 100%. And we get about 23.13%. This means that about 23.13% of students are within the normal weight range, meaning that their BMIs are in between 18 and 24.